Have you ever looked up at the night sky? Have you ever felt that sense of wonder? The stars seem so far away, part of a vast, silent universe. This is the world of cosmology. It is the study of everything big. It deals with galaxies, black holes, and the beginning of time itself. It's about the grand scale of reality, a stage so enormous it's almost impossible to comprehend. But there is another world. It is a world hidden from our eyes, a world that exists on a scale so tiny it defies our everyday intuition. This is the realm of quantum physics. It's the study of atoms, electrons, and the strange particles that make up everything you see. You might think these two worlds have nothing to do with each other. One is about the immense, the other about the infinitesimal. But the most incredible scientific discovery of the last century is that these two stories are actually one. Let's think about what everything is made of. Your chair, the air you breathe, the phone in your hand. If you could zoom in further and further, past the molecules, past the atoms, you would find a world of tiny fundamental particles. One of the first and most mind-bending rules of the quantum world is the Heisenberg uncertainty principle. It says that a particle, like an electron, doesn't have a definite position until we look at it. It exists in a cloud of possibilities. Here is another idea from the quantum world that will challenge your intuition. Everything is both a particle and a wave. If you fire electrons, one by one, through a barrier with two thin slits in it, something truly bizarre happens. Now let's zoom out. I mean really zoom out. We're going to expand our view past our planet, past our solar system, and even past our own Milky Way galaxy. We are entering the realm of cosmology. This is the science of the universe as a whole. The first thing you need to know about it is that it is expanding. It's not expanding into anything. Space itself is stretching. This is precisely what we see when we look out at distant galaxies. They are all moving away from us. And the farther away they are, the faster they appear to be receding. If the universe is expanding, we can, kind of run the movie backwards in our minds. What would we see? The universe would have been a sea of fundamental particles, a super hot, super dense soup. This is the hot Big Bang theory. The theory predicted that the intense heat from the early universe should have left behind a faint afterglow of radiation, filling all of space. Thanks to fantastically sensitive space telescopes like the Planck satellite, we have mapped this ancient light in exquisite detail. The inherent uncertainty of the quantum world created tiny energy fluctuations in the fabric of space-time. Inflation then took these microscopic quantum-scale jitters and stretched them to astronomical proportions. The stars, galaxies, and gas clouds we can see only makes up about 5% of the total energy and matter in the universe. About 27% of the universe is made of something we call dark matter, and a whopping 68% is made of an even more mysterious dark energy. There's another place in the modern universe where the two great theories of physics collide, at the heart of a black hole. He showed that, due to quantum effects near the edge of a black hole, black holes are not completely black. They should glow, ever so faintly, with a trickle of particles. Another quantum phenomenon, known as entanglement, shows us just how deeply interconnected the universe can be. We can send one to London and the other to Sydney, thousands of miles apart. When the experiments were finally performed with enough precision, the results were clear and unambiguous. The universe is as spooky as quantum mechanics says it is. There is no hidden information. In the 1990s and 2000s, a series of space-based telescopes, culminating in the European Space Agency's Planck satellite, mapped these ripples with incredible precision. These patterns are the direct evidence of the conditions in the infant universe. They are, in a very real sense, the echoes of the Big Bang's first moments. When scientists compared the precise data from the Planck satellite with the predictions made by the theory of quantum inflation, the match was perfect. The largest scale structures we can possibly observe in our universe have a pattern that is flawlessly explained by the laws of the very smallest things we can imagine. Yet for all that we've learned, our map of reality is still filled with vast, unexplored territories. One of the largest blank spaces on our map is the nature of dark matter and dark energy. The great quest of modern physics is to complete this journey, to find a single, unified theory that can describe all the forces of nature. One of the most famous is string theory, which proposes that the fundamental particles we see are not points, but tiny, vibrating strings of energy. You might wonder why we embark on this difficult and abstract journey. But this quest isn't just about satisfying abstract curiosity. When scientists were first developing quantum mechanics in the early 20th century, they had no idea that their work would lay the foundation for the entire digital revolution. Learning about the vastness of space and the incredible age of the universe can be a deeply humbling experience. Understanding that we are all made of stardust, forged in the hearts of long-dead stars from particles that obeyed quantum laws in the first seconds of the Big Bang, connects us to the cosmos in a profound way. So, we find ourselves at the end of our brief tour, standing on a shore of knowledge, looking out at a vast ocean of mystery. We began with two seemingly separate worlds, the immense silent dance of galaxies and the strange, fuzzy reality of the subatomic realm. We've seen how these two worlds are not separate at all, but are two sides of the same cosmic coin. The next time you look up at the night sky, I hope you see it a little differently. Don't just see the points of light. See the 13.8 billion year story that brought them into being. You are a part of this grand, interconnected cosmic web. The universe isn't a cold, distant machine operating independently of us. It's a dynamic, evolving, and deeply weird place, and we are an intimate part of it. The quest to understand the universe is a journey home. It's a source of endless wonder, a story that should fill us with awe and inspire us to keep looking, keep questioning, and keep exploring. Because honestly, the most beautiful thing we can experience is the mysterious, and it's the source of all true art and all true science.